Hey guys, Robert here with a tech talk from DTL Tactical. I'm just going to quickly review the manufacturing process for the FIDUS Everyday Carry Multi-Tool, which is our new product we introduced just recently. So what we have here is a series of the progression of the manufacture of the multi-tool. What's not shown is the raw material. I have a little piece of cardboard to illustrate that. We start off with 1/4 inch thick brass that's saw cut to length. Then a 1/4 inch and a 3/8 hole are drilled in it. Now these go into a fixture which holds 5 in series, so there's 1, 2, 3, 4, 5. And you may ask, why different diameter holes? Well, reason is that it's not possible to put the part into the fixture incorrectly. It will only fit in the proper direction. So after we cut those, drill them, we mount them in the fixture, we end up with a unit, or I apologize, these features weren't machined in, this was a setup piece, but it would have all the outer profiles complete. This slot would be machined in and all the outer chamfers would be complete. So the next process brings us to this point where now we're able to hold it in soft jaws on a Kurt vise in the CNC mill. And we use this upper profile here and these 2 radii to position the part. So there's 2 pieces in the vise, one here, and this profile here controls where they are on the x-axis. And then we can do the internals, we can flip it, and we can get all the chamfers on the back side, and also the keychain loop feature on the back side. Now the difference between these 2 parts, we have, this is the as received surface finish, and this has a tumbled and abrasive blasted media finish, which gives us a nice uniform tone. You'll also see that this hole is countersink and it's drilled through. This is countersunk, counterbored, where it's been bored out a little and then it's been tapped. So the operation that's not shown here is we actually get the part to this point and then I form tap it. Now I form tap it instead of cutting the thread, because when you form tap, you improve the material properties in the thread region, which allows for a much stronger thread. And in addition to that, the reason I tap it and then counterbore it is to remove the first couple of threads, because the first couple of threads are always deformed. They're never true form threads. So this allows to have the strongest possible thread in 360 brass. I mean, the hardware for this will be torqued to 15 inch-pounds, which is pretty substantial for a 440 screw. So next I do my engraving. I may personalize it with some up to 11 characters here. I can change the state, may use a zodiac symbol. We may put a company logo on either side or both. The absolute last operation is the slit saw operation. And it's absolutely last because I want that the most controlled feature other than the thread of this entire product. Because when that blade slides in, I get a slight interference fit, extremely tight. And with the combination of the 15 inch-pounds of torque and the cleanliness of this being just cut and then soaked in acetone to relieve it of any impurities, I have never had a failure in the fact that the blade has moved. I mean, I've done lots of testing, cutting all sorts of materials, and I've never had that blade move. Well, that's a little bit about how it all happens, and if you have any questions, please email me. Thank you.